So up to this point, in Unit 2, we have classified, we have added, subtracted, we have multiplied polynomials. Monday and Tuesday, we talked about the binomial theorem, where we use Pascal's triangle to help us expand or multiply out those binomials when I've got higher powers, okay? Today, we're also doing something new. You have not done polynomial division. Okay, and we're going to do two different ways to do this. The first way, I'm just going to go ahead and tell you, you're absolutely gonna hate, okay? You will hate it. But we still need to learn the process, and then I'm going to teach you a way that hopefully will relax you a little bit, okay? All right, so let's start out right here with polynomial long division. But I want you to notice that we are going to divide a polynomial by this monomial, okay? So I've got a bunch of terms being divided by one term. I'm going to rewrite this in a different format. I have 36n cubed plus 3n squared plus 2n, and that whole polynomial is going to be divided by 9n cubed. Okay, 9n cubed. Now, if you remember back to quadratic formula or complex numbers, anytime I divide a whole thing by this one little thing, this piece in the denominator belongs to every single thing. Okay, it doesn't want to get left out, so I got to give it to everything. So I'm going to rewrite it where I've got individual little fractions. So I have 36n cubed divided by 9n cubed plus 3n squared divided by 9n cubed, and then 2n divided by 9n cubed. Notice all the denominators are the same thing because that's what I'm dividing by. Okay, now here, I'm going to look at each fraction separately, and I'm going to reduce what I can. I see n cubed divided by n cubed, and I know that that's just going to cancel out. But I'm left with 36 divided by 9. What does that give me? 4. Okay. Then I have 3 over 9. What does 3/9 reduce to? 1/3. But I still have these n's to consider. Now, n squared is the same thing as if I write out 2 n's up top, and n cubed is if I have 3 n's. For every one on the top that I have one on the bottom, I can cross it out, right? So if I cross out those 2 n's, I can cross out 2 n's in the denominator. How many am I left with, and where is it? 1 on the bottom. So 1 n in the denominator. So that fraction right here, 3n squared divided by 9n cubed, becomes 1 over 3n.
So why do you do it on the bottom?
Because I was able to cancel out the 2 up top, so they're completely gone up top. I have 3 in the bottom, and I was only able to cancel out 2 of those 3. So I'm still left over with 1, and its location is in the bottom. I can't pull it up. I can't change its location. Okay? All right, now 2/9. Does that fraction reduce? No. But here I have an n, and I have an n cubed on the bottom. How many of those n's am I able to cancel out? Only 1. So if I cross 1 out on the top, 1 out on the bottom, what am I left with? 2 over 9n squared. Okay, so this is my final answer. Okay? Yeah, this is not that bad. Dividing a polynomial by a monomial, really easy. Okay? Now, Rather than writing it out 2 separate times, I'm going to skip a step on the next problem, okay? So here is number 2, okay? I'm going to write out 2x to the 4th plus 8x cubed plus 3x squared. And I know, based on what I just did in number 1, that this 4x squared is going to divide every single term. So I am going to go ahead and write that as the denominator of every single one. Okay? So I'm going to start right here. I've got 2/4. What does that reduce to? 1/2. All right. Then I have these x's to deal with. Up here, it's like I have 4 x's, and down here I have 2. I'm going to cross out 2 of them. How many am I left with, and where are they?
2.
X squared at the top. Good. All right, now I'm going to write this in different ways in just a minute. So there's a lot of different ways you could write this and it would be equivalent, okay? All right, what is 8 divided by 4? 2. What is x cubed divided by x squared? Just x. Does everybody see how I could have written this over 1 and it still give me a fraction? But I really don't need to do that. I want to write it as simple as possible, okay? All right, then over here I've got 3/4. The fraction does not reduce, but these x squareds cancel each other out. So I have 3/4. Okay, so this is one way that I can write this, and it's fine. I could also write this without the 1 up top, because there's an understood unwritten 1, right? Yes? Hey, you can speak to me, it's okay. All right, and then the other way, I could simply write a 1/2 out front and pull the x squared over to the side and have plus 2x and then plus the 3/4. Either one of these 3 options is totally fine for writing your final answer. You pick what you're comfortable with and I will go with that, okay? But if it's multiple choice, however it's given, you need to be able to recognize it, okay? Any questions so far? You feel pretty good? Awesome. Let's look at number 3, please. Number 3. I have 20n cubed plus 20n squared plus 3n, okay? And I'm going to write it out. And this time, what am I dividing by? Just 10. I don't have any variables to worry about. What is 20 divided by 10? 2. So that becomes 2n cubed. 20 divided by 10 again is another 2. So that's 2n squared. And then what about this? 3n over 10. Does anything reduce?
No.
It's exactly the same. And I'm going to leave it just like that. You could write this with 3/10 as a fraction out front and the n out behind it. That would be fine. Okay? All right, I want for you very quickly to do number 4. I want you to try it. We'll check your answer in just a second. Okay, checking your work. Check yours against mine. When everything cancels out, can I put 0? What is anything divided by itself? 1. Okay? Five will go up top. Here I cross out 2 of my n's, so that leaves me with 1 down here in the, not n's, k's, and that leaves me with a k in the denominator. How'd you do?
I put 5K, that's what I did too.
Okay, so remember, I can't pull this up from the denominator. If I have more k's in the bottom than the top, I'm going to be left over with the k's in the bottom. I can't pull it up. So that would not be 5k, okay? That does happen. That's a common mistake. So just be careful with that, okay? Are we okay dividing a polynomial by a monomial? Just simplify individual little fractions, okay? All right, next, flip it over to the back. And this is where you'll notice that it changes just a little bit. Right here, I have this ugly polynomial divided by a what? A binomial. I've got 2 pieces, okay? Before we do this, I want to come over to the side over here. Okay, and I want to do a quick reminder of elementary school long division. Okay, so I want you to do 2,157 divided by 3. Let's talk through this. 3 will not go into 2, so I extend it to the 1. How many times will 3 go into 21? 7 times. What do I do next? What do I put here? 21. What did I do? I multiplied 3 times 7, and I wrote that number, okay? What's my next step? Not yet. I got to come through and subtract, right? So if I subtract, that 21 cancels out, and then I can bring down the 5. How many times will 3 go into 5? 1 time. 1 times 3 is 3. And I'm going to subtract here. 5 minus 3 is 2. And I will bring down my 7. How many times will 3 go into 27? 9 times. 9 times 3 is 27, and that gives me a pretty 0 remainder, okay? We like 0 remainders in Algebra 2. You'll find out why in just a little bit, okay? But not everything is going to have a 0 remainder, okay? We will have remainders we still have to work with. Now, carrying this elementary school idea to what we're about to do. Okay, we're going to, first of all, check and make sure that I have every single term, okay? I have b to the 5th. That's my highest power. It goes 5, 4, 3, 2, 1, 0. Am I missing anything? No. We're going to have to write kind of small, okay, because this problem is going to take up the majority of this space and probably bleed into a little bit more space. This is what I'm telling you you're probably going to hate, but we're going to suck it up and we're going to deal with it anyway, okay? Because one of your questions on your quiz on Friday, you will have to do long division, okay? Only one. Everything else, I'm going to teach you a better way, okay? An easier way. All right, so I'm going to start out with my divisor. That's the b minus 10. And I'm going to write it over here on the outside of my division bar. Since I'm not missing anything, I don't have to worry about filling in any holes. I'm going to very carefully write down the rest of my problem, making sure that I keep this fairly small. Okay? It's a long problem, isn't it? All right, and as I'm working on this, just like I did with the 3 as my divisor over with the elementary school problem, I am only going to look at this b. Okay? What can I multiply by b so that I end up with b to the 5th power? How many more b's do I have to multiply it by? 4 more, not 5. 4 more. B to the 4th times b is b to the 5th power. But is b to the 4th only multiplied by the b, or how many pieces do I have here? I have 2. So I'm going to have to treat this like I'm doing the distributive property. So b to the 4th times b is b to the 5th. B to the 4th times negative 10 is negative 10 b to the 4th. Okay? So each time I do this, I'm actually going to end up with 2 terms that I'm working with. Now, after I multiplied, what was my next step? Subtract. So I'm going to come through and I'm going to subtract. But what if I end up subtracting a negative? I end up changing it to addition. I circle my signs that I have changed them to just so I don't accidentally do the wrong thing, okay? Now, this first one cancels out because that's b to the 5th minus b to the 5th. What is negative 14b to the 4th plus 10b to the 4th? Negative 4b to the 4th. Be confident. Y'all speak up. You're right. Okay? And I'm going to go ahead and I'm going to bring down the rest of my polynomial just so I keep things leveled up. Okay, so all I did was just bring that down. Now I'm done with this underneath the division bar right here. I'm now going to look right here. What do I need to multiply by b so that I get negative 4b to the 4th? Negative b to the 3rd power. I hear you over there. Good job. Negative 4b to the 3rd power. Yeah, I kind of squished that in.
I think you forgot the 4 when you said it a second ago.
Oh, I'm sorry. Yeah, negative 4b cubed. So I'm going to take this number and I'm going to distribute it to both of these pieces. Negative 4b cubed times b is negative 4b to the 4th. And negative 4b cubed times negative 10 is positive 40b cubed. I'm still multiplying my numbers like I always would, okay? Now I'm going to come through and I'm going to subtract. Anything that was negative becomes positive, and anything that was positive is now negative. So these are opposites and they cancel each other out. All right, what is 36b cubed minus 40b cubed? Negative 4b cubed. And again, I'm going to drop down the remaining pieces. Okay? See how this is taking up a lot of space? Just wait till you get to college, and one math problem in a college algebra class takes you like a full page front and back. That happens. Okay? Right here, what can I multiply by b so that I end up with negative 4b cubed? Negative 4b squared. Great job, hun. So I'm going to distribute this, okay, to both the b and the negative 10. Negative 4b squared times b is what I want, the negative 4b cubed. Negative 4b squared times negative 10 is 40b squared. So I'm going to come through and simplify this. I'm going to subtract. Any minus stuff turns to addition, and any pluses turn to subtraction. Yep, I want these to be opposites. Okay, so they cancel each other out. What is 50 minus 40? 10. So 10b squared. And I'm going to drop the negative 93b and the negative 78. What now can I multiply by b so that I get 10b squared? 10b. So plus 10b. So that's 10b squared. And then positive 10b times negative 10 is negative 100b. If I come through and subtract, my front terms cancel out because they were opposites. What is negative 93 plus 100? 7. So I've got 7b, and then I drag down the minus 78. So it's bleeding into my other problems a little bit. I'm sorry about that. Okay? What can I multiply by 7b? I'm sorry, by b that's going to give me 7b? 7. So positive 7. 7 times b is 7b, and 7 times negative 10 is negative 70. So one more time, I'm going to come through and I'm going to subtract. That becomes a minus and that becomes a plus. The 7b's cancel out. And what is negative 78 plus 70? Negative 8. Can I multiply b by anything that's going to give me negative 8? No. So I'm done, but this is my remainder, right? Y'all remember having remainders that you had to write somehow in elementary school? Here's how we're going to do it here. Whatever my remainder is, if it's a negative 8, I'm going to come up here and I'm going to do minus 8, and that's going to go on the top of a fraction, okay? And underneath it, I'm going to put my divisor, which was b minus 10, because I'm still dividing it by b minus 10. That was just my leftover stuff. This whole thing up here is what I call my quotient, which is the answer to a division problem. Don't you love long division? I mean, really, it's not fun, okay? So, let's skip over number 6. Since I kind of bled into some of its space, let's skip to number 7, please. That was the answer. This whole thing right here with the remainder stuff, that's my answer. That's my quotient. Okay? Here for number 7. All right, my divisor is m minus 5. What I am dividing, my dividend, right here, I have 3m cubed minus 15m squared. What's missing? An m to the first power. Okay? And I've got the minus 9. Anytime I am missing something, I have to plug in a placeholder. What represents nothing? 0. So here we go. Here's how I'm going to write it. I've got 3m cubed minus 15m squared. I'm going to write plus 0m, and then I've got minus 9. So my powers now go 3, 2, 1, 0. Okay? So I've got something in every place. I'm going to concentrate on the m. What can I multiply by m so that I get 3m cubed? 3m squared. Notice I'm kind of trying to keep those lined up on top of the ones that have the same term. Okay? 3m squared times m is 3m cubed. And 3m squared times negative 5 is negative 15m squared. Okay? When I come through to subtract, what do you see happening? They both cancel out. Okay, they were both opposites. So here, I can drop the 0m and the minus 9. Okay? Now, can I multiply m by something to give me 0m? 0. But does it make sense to put plus 0? No. So technically I'm done, okay? I'm just going to ignore that right there, and then this is going to be my remainder. So I have 3m squared. This is a negative 9, so I've got minus 9 over m minus 5. Are they always ugly like the first one I did? No. Because I want you to thank me later for what I'm going to teach you. I got to start hard first and then make it easy on you. If I made it easy on you at first, then y'all would whine and complain as I got harder, wouldn't you? Okay? All right. Next, let's look at number 8. Okay? Number 8. Right here. I'm going to check my powers. I have 3, 2, 1, 0. Am I missing anything? No. So I'm going to set up. I've got p minus 9 dividing into p cubed minus 13p squared plus 40p minus 43. So I have p that I'm focusing on. What can I multiply by p so that I get p cubed? P squared. P squared times p is p cubed, and p squared times negative 9 is negative 9p squared. So I come subtract. If it was negative, remember it turns positive. Those cancel. What is negative 13 plus 9? Negative 4. So negative 4p squared. And I'm going to drop this other stuff down beside it. What do I multiply by p so that I get negative 4p squared? Negative 4p. Because I got to multiply p times a p to get the p squared. Okay? So this is negative 4p squared. And negative 4p times negative 9, positive 36, and that will have a p attached to it. If I come through and subtract, all it does is change my signs. This first part cancels out. What is 40 minus 36? 4. So 4p. I drop the 43. What am I going to put up here next? What can I multiply by p to give me 4p? 4. 4 times p is 4p. And 4 times negative 9 is negative 36. Subtract. Change the subtraction to addition. That first part cancels out. Okay? What is negative 43 plus 36? Negative 7. All right, so this right here is my remainder. Okay? So I'm going to take the minus 7. I'm going to write it as a fraction, and what's going on the bottom? Good. Very good. So this right here would be my answer. That's the quotient. Okay? Show of hands, who likes long division? I didn't think that I would see any. Okay? So now I need for you to take your paper, stick that one to the side, and let's look at synthetic division. What does synthetic mean? Fake. Okay? So this is going to be a little shortcut. I love synthetic division. It's my favorite thing about Algebra 2. Okay? My favorite thing. Maybe other than rational, simplifying rational stuff, but that comes second semester. It's difficult, but I love it. I'm a nerd, and I'm okay with that. Okay? All right, so right here, synthetic division. I still have to check and make sure that I have every term. So I have 5, 4. Oh, what's missing? The 3. Okay, so I'm missing an into the third. Keep that in mind. Then I've got 2, 1, 0. All right, so right here, we're going to set this up with an upside down division bar. Okay? Now you notice on this paper that you've got, I've got a lot more problems on the front side of the page, and I have not given you much room at all, have I? Okay? You don't need much room. So watch this. I am going to take my divisor. This is very important, okay? I need to know what it would be, or what my solution would be if I set this equal to 0 and solved. How do I get rid of a minus 9? Add 9. So, because this is 9, I'm going to put a positive 9 on the outside of my synthetic division. Okay? Now, do not put the negative 9 because that's not what we're checking. In Unit 3, which we're headed towards, we're trying to check and see if these numbers are roots or solutions of this polynomial. Do y'all remember when we factored and we broke each factor apart and set it equal to 0 to solve? that number would be a solution, okay? So it has to be, I have to set this equal to 0 and solve. All right, so right here, inside, I don't even have to worry about my variables and my powers. This is the really nice thing. I get to kind of just omit them for right now. I'm going to write the coefficients down inside. Now, yesterday we said the coefficient is the what? The number out in front of the variable. Good. All right, so highest power was 5. Its coefficient is 1. Next highest power was 4. Its coefficient is -9. Wasn't I missing the next one? I'm missing n cubed. So I do. I need to put in 0. I have to have a placeholder for n cubed. What would I write next? 8, then -81, and last 86, which is my constant, okay? Now directly underneath my 86, at the bottom of that synthetic division, I'm gonna draw a little box right here. And this little box is gonna represent my remainder. Whatever number is in that box is the remainder of the quotient. Here's my process. It's very simple. No matter what, I will always drop whatever this first number is to the bottom on the outside of the division. On the outsides, we will multiply. So any number that's outside, I'm going to multiply. So 9 times 1 is what? 9. I'm going to write that number in the next place, inside. So outside we multiply. We write our product in the next place. And vertically, we are going to add these numbers. What is -9 plus 9? 0. Okay, and then I'm going to multiply again. What is 9 times 0? 0. So that is going to be written in the next place. And then I add again. What 0 and 0 give me? 0. Then I got another 9 times 0. Notice I'm skipping over the other stuff. I'm not going to multiply it by these pieces again. I've already used them, okay? So 9 times 0 again is 0. But this time when I add them, I get a sum of 8. Then I'm going to do 9 times 8, which is 72. I'm going to add those two numbers, and I get what? -9, good. And then 9 times -9 is -81. And what is my remainder going to be? 5. 86 minus 81. Yes. Now, here I use the coefficients of my dividend, my polynomial that I was dividing, okay? So these that I get here are the coefficients of my quotient. But before I do this, I started out with n to the 5th, and I divided out n. What is n to the 5th power divided by n? N to the what power? Look, if I do n to the 5th power divided by n,
Oh, into the 4th?
No, it was, I think it was
okay? N to the 5th divided by n. I have 5 n's up top and I have 1 on the bottom. I can cross out the 1 on the bottom and 1 on the top. So how many am I left with? 4. So if I divide out n from n to the 5th, this is now going to be n to the 4th. This will be n to the 3rd, n squared n. This will be my constant, and this number right here will be my remainder. So I'm basically just dropping my starting exponent by 1 power. Okay? So right here, here's how I write my final answer. I have 1 n to the 4th. Do I need to write the 1 out front? No, it's understood. I have 0n cubed, 0n squared. I don't need to write those.
Plus 8n.
Plus 8n. Minus 9, and then I have a positive 5 for my remainder. So I'm going to do plus, and then 5 on the top of my fraction. What was my divisor to begin with? N minus 9. I've got to go back to my original polynomial and write that as my answer on the bottom. So this is my quotient. So since I had a remainder, does it divide into it evenly? No. Okay? Let's look at number 2, please. I'm going to set up my upside down division bar. I'm going to go ahead and work with my divisor. This time I have -2 plus x equals 0. How do I get rid of this -2 out front? Add 2. So on the outside, I'm going to put a positive 2. Then I come to my dividend, okay? I've got 10x cubed minus 20x squared. Then am I missing something? I'm missing just my x term, right? So what am I going to have to put in its place? A 0. And then I've got the -8. So I've got 10, -20, 0, and -8 as my coefficients. I'm going to put my little box underneath. What does that represent? My remainder. Good. All right, you got it set up? No matter what is up front, I'm going to drop it to the bottom. And then I start multiplying on the outside and doing what on the inside? Adding. 2 times 10 is 20. -20 plus 20 is 0. 2 times 0 is 0. I get a sum of 0. I get another product of 0 because 2 times this 0 is still 0. What is my remainder? -8. Now I started with x cubed. So if I drop it a power, this one is what? X squared. This is x. This would be my constant, and this is my remainder. Do I have much to write down at all?
Nope.
10x squared. It's a -8, so minus 8 over -2 plus x. Aren't you so glad I'm not going to make you do everything doing long division? I'm telling you, synthetic division is awesome, okay?
They said I don't like this either.
Look, you got to choose the lesser of two evils, okay?
I mean, do long division then. It's just gonna take you longer.
That's right. You're still going to get the same answer, but this is way quicker, okay? All right, here we go. Number 3. I'm going to set up my upside down division bar. What number will I put on the outside? -1. Okay, I don't always have to show that step right here. Okay, if you can look at that and very easily pick out what's going to go out there, I'm fine if you don't show that. Look at the inside of my parentheses here, though. What's the problem? It's out of order. We cannot put it down how we see it. We have to make sure it is in order. So right here, n to the 5th is the highest power that I see. Its coefficient is 1. What would the next highest power be?
1 again.
No.
4.
4 is my next highest power. Its coefficient is also 1. What would the next highest power be? I've got highest power is 5, highest power is 4. So next would be third power. Do you see that? So I put a 0. Then the next highest power would be 2. I gotta put another 0 because there's no n squared. Do I have an n?
Yes.
Yes. Positive 4. And then my constant is also here, and it is negative 4. So remember, underneath my constant, I've got to draw my box for my remainder.
It says you draw your box under the last one.
Under the very last one. That's right. Okay. So I'm going to drop my first number. So I got a 1 on the outside. What's negative 1 times 1? Negative 1. And I add those two together. Man, I get 0 again. That's not always going to happen, by the way. Okay? Multiply negative 1 times 0. 0. Sum of 0. Another product of 0. Another sum of 0. Here, another product of 0, but this time my sum is 4. Negative 1 times 4 is negative 4, so my remainder is negative 8. Okay? I started with n to the 5th, so this is going to be what? 1 n to the 4th, third, second, first. This number right here is just going to be a constant. And I have negative 8 as my remainder. And what will I put it over?
N plus 1.
N plus 1. Okay. That's my answer. I'm going to put a box around it. And I'm going to move to number 4. Okay? Number 4. Set up my upside down division. What number goes on the outside? 1. Checking my powers. 3, 2, 1, 0. Do I have to put any zeros in this time? No. And it is in standard form. So I've got 7, negative 2, negative 8, and negative 3. Put my box for the remainder. Drop the 7. 1 times 7, 7. What's negative 2 plus 7? 5. 1 times 5 is 5. My sum is negative 3. I get negative 3 here. So my remainder is negative 6. Okay? I started with x cubed. So this is now x squared plus 5x minus 3, and then minus 6 over x minus 1. Okay? That's my answer. All right, flip it to the back for me real quick, please. And let's look at number 9 and number 10. My directions are a little bit different here, okay? They say, state if the given binomial is a factor of the given polynomial, okay? Now, this is going to be important to us when we get into Unit 3. Right here. I basically want to know, is it going to divide in evenly, or am I going to have a remainder? If it divides in evenly, what would my remainder be? 0. I wouldn't have anything left over. So, let's set this up. What number will go on the outside?
Negative 6.
Negative 6. Checking my powers. 5, 4, 3, 2, 1, 0. Nothing is missing. So I'm going to write down my coefficients. And I'm going to put my little box down there at the end. What do I hope to have? 0 remainder, okay? I'm telling you, we like 0 remainders in Algebra 2. 1, -6, 4. Are you following? Multiplying on the outside, adding on the inside, okay? -24, -4, +24, 10, -60, 8, -48, look at that, 0. I got what I wanted. If I get a 0 remainder, that means, yes, this is a factor. You're going to have to factor this big old long thing in Unit 3. We've only factored quadratics, okay? So if it factors with a 0 remainder, my answer is yes. But what if I get a number in here? It would be no, okay? Look, your homework, okay, your homework is to do 5, 6, 7, 8, 10, 11, and 12, okay? Have a good day.